Assalamu alaikum. In this video lecture, we are going to cover the contents of Module 7. In Module 7, we will be basically looking at the ways of solving differential equations. Before we move into the methods of solving differential equations, let us first have an overview of what differential equations are. Differential equation is basically an equation like any other mathematical equation, but the difference here is that it involves derivatives of this order, like dy dx, del I del x, in this way. Okay, and these equations involve these types of derivative where there are two variables are involved. One is dependent variable and another one is independent variable. I have marked them in different colors. If we take this for an example, this is dy dx. Here y is the dependent variable and x is the independent variable. As a whole, what differential equation actually tries to convey, it basically tells us about rate of change of both of these variables. So they form a mathematical relationship through which they want to tell us that there is a change of y with respect to change in x. This y and x can be replaced by any physical quantity that we use in day-to-day life physics or any other types of function that we can describe using mathematics. For an example, let's look at one differential equation. This is one of the examples of differential equation. So if you are given a differential equation and you are asked to solve it, what does it mean? You are basically asked to solve for y. You are asked to complete a function that represents y, of which if you differentiate that y, you eventually get this thing as a result. So now the question is, how can we solve it? Okay, one way you can think of solving it is by integrating both the sides. How you can integrate both the sides? This can be one of the methods. Okay, if we integrate this given differential equation that is at our hand, and if we run the integration, we end up with this type of a solution. Okay, still we haven't reached a definite conclusion, because if we look to plot this function in our graph, this will actually vary for different values of c. Look here, we have kept the values of c varying from minus 2.5 to 2.5, and once when the value of c will be varying, see how the function varies along the x axis and y axis. Okay, so if we keep the solution in this format, this is not a definitive solution. So how can we come up with the exact solution of a differential equation? One possible way can be if some initial values of that problem is given to us. Using that initial value, we can pinpoint a value of c, and then we can come to a conclusion that we have found a conclusive solution of our given differential equation. Let us take for an example, for this particular differential equation, the initial value is given at x0, y is 2, and if we plug these values into the equation, we get the value of c to be 2. That means for this condition, the solution of the given differential equation is a definitive solution, and it will look like this on the graph. Well, now that we have established our relationship up to this, the main idea here is that if we are given a differential equation and if we are asked to solve it, we will be basically solving for the dependent variable y, and we will try to come up with a function that describes y, and that also should be able to describe the differential equation given. If we differentiate the given y here, or the y that we have calculated, if we differentiate it with respect to x, we will get to the version that was given to us as the first question. With the discussion we have had so far, we have seen how we can solve any differential equation that is given to us, and by solving a differential equation means we are basically looking at coming up with the function of the dependent variable and generating the corresponding graph of that function. Now, if we are asked the same questions that solve the differential equation using any numerical methods, how would we approach that problem? We would definitely not solve it by integrating both the sides of our differential equation. Rather, we will look to solve it intuitively. What does it mean? It means that using numerical methods, we would be solving for different points on the graph, and our goal will be to construct the function used in graphical method. Rather, we would be looking to solve it graphically. Using numerical methods, we will try to generate a graph that is much closer to the original solution of the differential equation. So that will be our idea going forward. So in the next part of the lecture, we will see how we can solve any differential equation intuitively using numerical methods.